Hello friends. So in last lecture we have seen a change of variable from your Cartesian to the polar system. So the purpose is to simple your calculation. I mean, we have taken one example, that is vibration of your circular membrane. So in this case, in this lecture we will see the theorem for differentiation. So as you know, this is f is a function of two independent variable. So this is x is a function of two independent variable. Now suppose this x is a function of the f and y. So how we can write this one? Suppose this x is a function of your f and y. Means x is depend upon two independent variable f and y, and this y is also a function of your f and x independent variable. Okay, so this is not big task. As you know, we have this is PV is equal to RT. This is ideal gas equation. Okay, so in that case we can write P is, suppose we write this is P is equal to, this is RT divided by V. So P is a function of your this is your gas constant, the temperature and volume. Okay, and V we can write in terms of R divided by P. So this is one and the same thing, so which we have to see here. So instead of F I will consider suppose J. Okay, so this is x is a function of your y and z. X is a function of, so f we have replaced with your z, so x is a function of your y and z, where y and z are independent variable. Then I can find out the total differentiation of x. So this is nothing but delta x by delta y into your dy plus delta x by delta z into your dz. This is one. Now second, suppose y is a function of your x and z. Okay, so here y is a function of your x and z. So we can write this is total differentiation dy, which is nothing but delta y by delta x into your dx plus delta y by delta z into dz. Okay, now we'll put this dy value over here. So please remember, this is your z will be constant over here, here y is constant. Okay, same thing will be, you are consider this is z is constant and over here is x is constant. Okay, so we'll put dy value in this equation. So equation 1, so put 2 in 1. So your dx equal to delta x by delta y at z is constant. Okay, into this dy value. So this is delta y by delta x into z dx plus delta y by delta z x dz plus this value delta x by delta z, okay, into y and dz. Okay, just multiply inside. So what you will get over here, this is delta x by delta y, z is constant, delta y by delta x into z into your dx plus delta x by delta y, z is constant, into this delta y by delta z into your x into your dz plus this term delta x by delta z into y into dz. So here dz is there, so I can take common. So instead of that, I will write over this value directly as a dz. So left hand side we have dx. Okay, so I will compare both the sides. So dx term, suppose I will compare, that time I will consider dz is 0. Okay, so z is constant means dz equal to your 0. So comparing both the sides, so what we will get, I will get this comparing the dx term. So that is nothing but 1 equal to delta x by delta y times z into delta y by delta x into z. Okay, so this term I can write in terms of what? This is delta x by delta y, z is constant, which is nothing but 1 divided by this. I will send to right hand side, so it is goes to the denominator, delta y by delta x into z. This is indicate what? This is indicate is nothing but your reciprocal theorem. Okay, so suppose I will write this. So this is delta y by delta x into z. So this is inverse of that particular term. So this is nothing but your first theorem of your differentiation, and it is called as your reciprocity theorem. Reciprocity theorem. Okay, so this is very simple. What we have taken, we have just compared the dx term over here. dz is 0 at that time, and I will get this is 1 equal to delta x by delta y, z is constant, delta y by delta x, z is constant, and I will get this reciprocity theorem. This is the first theorem. So these are the two variables. One variable should be always constant. So here please remember, delta x by delta y, it changes, z is constant at that time. Okay, equal to 1 divided by delta y. So this is delta x by delta y. Okay, z is constant. Second, you are reverse, delta y by delta x, and z is constant. So one parameter should be constant, and you will get one theorem, that is your reciprocity theorem. So probably this theorem you have seen in electronics also. Okay, so I will not go into the detail, but what is the application over here? So we have to consider one unidirectional network, okay, and which has excitation as well as your response. Okay, so this is your bidirectional network. So this is a linear bidirectional network, single source network. So this is my source. I will explain a little bit in detail. Okay, so please understand the concept only here. It might be applicable or not. So theorem is a linear bidirectional single source. Okay, bidirectional means both the side. So this is your network, and which has your single source. Okay, so positive, negative. Suppose this is your voltage, and this is X branch, this is your Y branch, and and this is my excitation. So source is only, so this is my excitation, and here I will get the current I can measure, means how much current we can pass through that particular circuit. So that is my response. Okay, so that things is nothing but what is a linear bidirectional single source network. The ratio of response to excitation is always constant. Okay, see here, that is the case same. Okay, suppose here you are changing your source. So this voltage is going suppose here, and you are measuring current over here, and you want to measure a response to your excitation, and that is always same or constant. Okay, so this is applicable to your ohms. Then second, once you have compare this first part, the second part we have compared with digit term. So here is no digit term, so I can consider plus 0 times. So that time your dx is constant. Okay, so now this is del bar x by del bar y, z is constant, plus into del bar y by del bar z, x is constant, plus del bar x by del bar z into y, which is equal to your 0. Okay, here is no digit term, so we have to take this. So I will send this term to the RHS. So what you will get, del bar x by del bar y into your z, del bar y by del bar z into your x, which is equal to minus del bar x by del bar z into your y. I will take this term again here, so that is nothing but del bar x by del bar y z, del bar y by del bar z into your x, and this is del bar z by del bar x into y, which is equal to minus 1. Okay, and the first theorem is what? Del bar x by del bar y z, which is nothing but 1 divided by del bar y by del bar x into your z. So please remember here, both the partial derivatives should be exist. If your del bar x by del bar y should be exist, as well as del bar y by del bar x should be exist, then and then we can see this particular theorem. Same thing will be here. So every derivative should be exist. Del bar x by del bar y, z is constant, del bar y by del bar z. So this is your second partial derivative. Okay, second theorem for your partial differentiation. Okay, so best example we have this one. So please remember, this is very simple. This is x, y and z. Okay, here in first theorem, this is z is constant, del bar x by del bar y, z is constant, equal to 1 divided by del bar y by del bar x, z is constant. Second case, del bar x by del bar y, z is constant, then del bar y by del bar z, x is constant. Okay, so you can del bar z by del bar x, y is constant. If you go in this way, so you will get the easily understood means the remember the statements of your theorem. So we want to verify these two theorem for ideal gas. So we know PV is equal to what? RT. So what is my function? P is a function of your okay, so this is nothing but V and T. Yes, so for that case, here we can write P is equal to what? RT divided by V. Okay, so temperature is suppose constant. So in this case, the first what? Del bar P by del bar V at T is constant. So del bar P by del bar V, T is constant. So this is nothing but minus RT divided by V square. Okay, obvious. This is 1 raised to minus 1. So this is minus V raised to minus 1 is 2 into this is 1. So this is minus 1 upon V square that we have written here. Okay, so this is 1. Reciprocity, del bar V by del bar P at T is constant. So that is nothing but, now only we'll take V over here. So in terms of this equation, V is what? V is equal to RT divided by P. So that is nothing but minus RT divided by your P square. Same thing. Now we have to multiply these two. Okay, so delta P by delta V at T equal to into delta V by delta P at T equal to, so we'll put both the values over here. So that is nothing but minus RT divided by V square, second RT. So we have to verify. So we put this one. So this is minus minus plus. So I will get here R square T square divided by V square P square. Okay. But we know PV is equal to RT. So R square T square is nothing but P square V square. So this is P square V square upon V square P square. So this is cancelled. So first theorem is verified over here. Okay. Now the second theorem I have to prove over here. So only replace X with P, Y with V and Z with T. Okay. So that thing we have to do over here. So we have already find out delta P by delta V. Second I am to find out what? According to this, delta V by delta T, delta V by delta T at P is constant. So this equation delta V. So this is RT divided by P, delta V by delta T. So this is nothing but R divided by P. Partial differentiation with respect to T is your 1. Then third, what we have to determine? This we have to determine delta T over delta P, and what is constant? Your volume is constant. So the equation becomes delta T by delta P, volume is constant. So the given equation I can write in terms of T. This is very important. So whatever the partial derivative, so this is your function. So that should be on left hand side. So T is equal to, I can write, this is PV by R. Now delta T by delta P. Okay. So delta T by delta P is nothing but your V by R. Now on LHS is what? We have delta P by delta V. T is constant into delta V according to this rule. Okay, that I want to verify, and delta T by delta P, just put their values. So this is minus RT divided by your P square into R divided by your P, okay, into V divided by R. Okay, so this RR get cancelled. Okay, now here I will get what? This is your minus RT divided by your here is V square, no? So here is your V square. So this one V is get cancelled. So what is remaining here? Minus RT divided by PV. But instead of PV we can put RT value. So this is minus RT divided by RT. So you will get this is minus 1. So second partial theorem is also verified over here. The first is your reciprocity. Both the partial derivative should be exist, and this is your second. So any function which is depend upon just here P, we can write in function of V and T. V is again function of P and T. So in that case this should be exist. Okay. So thank you.